In the question number 31, among the following speed of sound at NTP is maximum in generally. You know sound travel fastest in solids. So my option number 2 will be the right choice. We'll move question number 32. In the problem number 32, the length of sonometer wire between two fixed end 150. If one fixed end as x equals 0, the opposition of two bridges, which ratio of fundamental frequency of three segments are 1:2:1. If I use the relation 1/2L tension and linear mass density for the frequency, as according to the problem, tension and linear mass density will remain constant, so I can find n inversely proportional to L. N means frequency, right? So if I write the ratio n1 to n2 to n3, will write 1/L1 for the first, L2 1/L3. So if I take n1 ratio n2 ratio n3, because that was our relation, but according to the problem I can write 1:2:1. So if I go for the length, because length is inversely proportional to n here, so we'll write L1 ratio L2 ratio L3. इसको reciprocal करना होगा, so 2:1:2 you will get. Now if I take L1 plus L2 plus L3, and that is 150 centimeter. But why? Because question says length of sonometer between two fixed end is 150. That's why I'm taking 150. So I can write, if I take the sum of these three, so we can write 150, that is equal 5k. K is the proportionality constant. So 5k is equal to 150, then I can say the value of k will be 30. Okay. Now, so I can find the value of L1, L2. L1 will be 60 because ratio is saying 2 times, and L2 will be 30. Similarly, L3 will be 60 centimeter according to the ratio that was given. So that I need x1 and x2 because two bridges. So first one is 60 centimeter because total sum was 150, so that is 90 centimeter. So this is the discussion of this problem. So question number 32, my option number 1 will be the right choice, x 60 or 90. So we'll move question number 33. In the problem number 33, the vibration of a string of length 300 centimeter fixed at both ends are represented by this equation. All units are in CGS. So we need to calculate nodes, number of nodes and anti-nodes. So before going to take the option, I would like to say something, because if I write the general equation, that is 2a sine kx cos omega t. So if I compare with this equation, so easily you can find the value of k. K means 2 pi upon lambda. In this equation, that is pi upon 30. Pi upon 30. Pi will cancel. So lambda you will get 60 centimeter. Because the separation between two nodes, node and antinode, so you know I need to calculate lambda by 2. So that will be 30 centimeter. Right? Now, so this is 30 centimeter, but total length was 300 centimeter. So when you will divide 30 by 300, you will get number of loops first. So if I write number of loops, so that will be 10. Now I am going to take number of nodes because nodes middle पर antinode होता है. So easily you can write number of nodes. 10 plus 1. 10 plus 1, that will be 11. Number of antinodes, very clear. Number of antinodes. That will be 10. So if I go for the amplitude at x equal 5, then I will use this relation. So for the amplitude at x equal to 5, we'll write 2a sine kx. So well, 2a is equal to 2. If I compare with this equation, 2 sine value of k is pi upon 30 according to the problem, and x equal 5. So when 5 6 are 30, so we'll get only 1 centimeter. Now I'm going to take my options. Total number of nodes 11 true, total number of antinodes 10 true, at x equal 5 this is true. So easily you can say option number 4 will be the right choice. We'll move question number 34. In the question number 34, a tuning fork having frequency 660 Hz vibrates just above resonance tube. The length of the tube is 0.5. If water level in the tube is slowly increased, the minimum height of water level required for resonance. Velocity of sound is given, neglect end correction. So you will not focus on end correction in the question number 34. Lambda is given by V upon F. F is the frequency. So first I need lambda. The value of V is 330 and frequency is 660. So I have 1 by 2 means 50 centimeter. This is the value of wavelength. Now if I go for lambda by 4, हमें ज़रूरत पड़ेगी lambda, lambda by 2, lambda by 4. So if I go for lambda by 4, because question says the minimum height of water level required for resonance. So I need lambda by 4. When you will calculate, we'll get 12.5. Next will be, because this is a closed organ pipe, so 3 lambda by 4. So you will get 37.5. If I go for the next, will 5 lambda by 4, because 135 in terms of lambda by 4. So when you will solve, you will get 62.5 centimeter. But the length of tube only 0.5 meter. So easily you can say this is not possible, right? So only first and second resonance can be produced. This one and this one, right? So minimum height of the water I can easily calculate H minimum 50 minus 37.5 in terms of wavelength, because we are going to ignore the end correction. So when you will subtract, we'll get 12.5 centimeter. So my option number 1 will be the right choice. We'll move question number 35. In the problem number 35, a certain organ pipe filled with oxygen resonance, its fundamental mode at frequency 600 Hz. The new fundamental frequency if oxygen is replaced by hydrogen at the same temperature, right? Because I know frequency is given by V by lambda, but there is only one change, the type of gas. So easily I can write F1 upon F2 V1 upon V2. But I know the formula of speed, that is gamma RT by M. So V is inversely proportional to 1 upon molecular mass. Because temperature is constant, so I can write V1 upon V2 in terms of mass M2 upon M1, because speed is inversely proportional to the mass. That's why V1, M2, V2, M1, right? Because temperature T is also constant. So I have the value of F1 upon F2. F1 is 600, F2 is our requirement, and M2, because oxygen is replaced by hydrogen. So second time mass will be 2, and initially that was 32 because oxygen was there. So we'll get 1 by 4. So when you will calculate this and this, F will be 2400 Hertz. So this is how you can calculate. My option number 1 will be the right choice. We'll move question number 36.